We talked about exponential functions. Those are ones that have x as the variable. For example, 2 to the x, f of x equals 2 to the x. Our variable, our independent variable, is in the exponent slot of this. 2 is our base. And then we talked about the inverse function, the logarithm function. In this case, the log base 2 of x. And I want to tell you that we did that on purpose. We called it the inverse function for a reason, because I want to now harken back to what we did a little while ago when we talked about f of f inverse of x. If you recall, that's equal to x. Well, here is my inverse function right here, the log of that base, and here is my function f. So when you see something what looks awfully complicated, like log base, say 3 of 3 to the 7.5 power, and you think, oh, logs, I need to be frightened. Stop it. Don't be frightened, because you will see that all I'm doing is taking the function 3 to the x power, and then I'm taking the log base 3 of that. I'm basically doing the inverse of the function, and I'm going to get that for my answer. It is simply 7.5. The reason is I am taking f of the inverse function. Actually, I'm going the opposite way. I'm doing f inverse of f of x here. This is the inverse function acting upon, composed with, the base function, the function that I started with. And it's simply that. It'll also go the other way. Let's suppose that I take 3 to the log base 3 of 82. That is going to simply be, this now is f acting on the inverse function. Here is my inverse function. Here is my function. And my value here is what my answer is. All because f of f inverse of x is x. Whatever's in this slot is that number. Whatever's in this slot is that number. Whatever's in this slot is that number. I hope that helps.